there are many fields in food analysis where comprehensive LC is a must. And this is very important. For example, we in our lab we analyze many different nutrients from food, but not only, but also contaminants. That is very important. You know, like the emerging contaminants, the regulation needs a very trace amount to be quantified. So just to give an example, as I did before, but here I can do with more detail. For example, when we deal with the proteins, and the normal approach with the proteins is to digest the proteins in a little molecule like peptides, so this is made with the normal LC. The problem is that when we couple the LC to mass spectrometry, and sometimes we would like to see the little components, but sometimes these components are co-eluded with the bigger components. So with MS, what happened that we have ion suppression. So the big ion reduce the signal of the little components. So the separation in comprehensive can be very interesting, and we can obtain better not only qualitative analysis, but also quantitative analysis. And for example, if we do separation of peptides, we can use an approach with the reversed phase. So the peptide analysis is very important when we do this in comprehensive LC with using reversed phase. So how we get to the orthogonality in this system is very easy. We play on the pH. So we have a completely different pH from the first dimension and into the second dimension. So we separate, we obtain a kind of orthogonality that is not like what we use with other technology when we use normal phase and reversed phase, but we still have very nice separation. And then for sure the MS help also if we have some overlapping. For example, another example of comprehensive LC that is very difficult, and we cannot obtain these results without comprehensive LC, is the analysis of phospholipids. Phospholipids is a class of components very important, not only for the nutritional point of view, but also because they are very bioactive components. And normally, if we give a look to the literature, these components are separated with Illich mode. And so the Illich mode, it's very important, but unfortunately, when we use only one conventional LC, the Illich mode separates phospholipids according to the class. So we have only the class of phosphatidylcholine, for example, but inside that class we have different phospholipids with different fatty acid in the two positions of the phospholipids. So the way of separating this fatty acid with the different hydrophobicity is to use reversed phase. So we can use reversed phase and we separate according to the hydrophobicity. But unfortunately, we overlap the one family with the other family. So there is no way in conventional LC to separate these components. So we successfully applied Illich separation in the first dimension and reversed the phase in the second dimension. So in this case, in the 2D plot, we obtain separation of the family in the first dimension, but then we see the blob coming up into the second dimension where we separate according to the hydrophobicity of these components.